For this video, we will continue to discuss the different uses of slope in coordinate geometry. But before that, let us recall the different formulas in getting the slope of a given line. So for the formula, the formula of the slope represented by the variable m, it can be rise over run or change of y over change of x. Or if you're given with points x sub 1, y sub 1, and x sub 2, y sub 2, we can use this particular formula, m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So, what are the other uses of slope in coordinate geometry aside from testing the collinearity of each points? Well, the other uses of slope is that we answer how do we show if two lines are parallel or perpendicular? Well, this is something about parallelism or perpendicularity of two lines. So, for parallel lines, we can say that two lines are parallel to each other if their slopes are the same or equal. While if they are perpendicular lines, then the slopes of each line must be a negative reciprocal of each other. Or we could say that if they are negative reciprocals of each other, then their products must be equal to -1. Now, if we're going to ask about what's the difference between the condition in parallel lines and collinearity, well, they don't have any difference. It will be just the same or equal. But how would I determine if it's collinear or parallel? Of course, we can always verify it by graphing the points given in the problem. So let us answer some examples using this particular use, meaning all of these questions involves parallelism and perpendicularity. So let's have number 1. For example number 1, we want to show that these points -7, 11, -11, 11, comma 5, 6, comma 11, and -12, comma -5 are vertices of a parallelogram but not a rectangle. So, what would be how are we going to answer this particular question? How do we show that these vertices are vertices of a parallelogram and not a rectangle? Well, the first thing that we could do is to graph the given values or the given vertices. So -7, comma -11. So let's say it's somewhere here. -7, comma -11. And then 11, comma 5. And then 6, comma 11. And let's say I'll just put it this here. Okay. -7, comma -11. And then the other one will be somewhere here. -12, comma -5. So, this one. Okay, so we want to show that this particular figure is a parallelogram, but not a rectangle. So let's try to label each points. Let's say this is point A, point B, point C, and point D. So, what should we do to test something that is or that forms a parallelogram? So, what is a parallelogram? A parallelogram is a quadrilateral with two pairs of parallel sides. So, meaning we have to establish that the opposite sides of this quadrilateral are parallel to each other. Now, how do we know that they are not, or how do we show that it's not a rectangle? Well, in this case, by getting the slopes, we can now establish or we can now see if they will form perpendicularity because as we know in terms of a rectangle, it forms four right angles, meaning each sides are or each consecutive sides are perpendicular with each other. So if we check all the slopes and we didn't find any negative reciprocals on it, then they will not form a rectangle. So let's look at each slopes. So for the first one, let's find the slope of AB. So let's say this is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So that's simply equal to 11 minus 5 over 6 minus 11. So this is equal to 6 over negative 5. So in this case, this is negative 6 fifths. How about measure of side BC? So measure of side BC, again, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So that's equal to 5 plus 11 over 11 plus 7. So that's equal to 16 over 18 or that is equal to 8 over 9. Next, the slope of CD. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. CD, so we'll have negative 5 plus 11 over negative 12 plus 7. So that's equal to 6 over negative 5 or negative 6 over 5. And the slope of AD, so y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for AD, we have 11 plus 5 over 6 plus 12. So that's equal to 16 over 18 or that's equal to 8 over 9. So look at this. The slope of AB is equal to the slope of CD and slope of line segment BC is equal to the slope of line segment AD. So we could say measure slope of AB is equal to slope of CD and slope of BC is equal to slope of line segment AD. Therefore, AB, line segment AB, is parallel to line segment CD and line segment BC is parallel to line segment AD. Thus, the quadrilateral ABCD is a parallelogram. And since the consecutive sides are not negative reciprocal of each other, then quadrilateral ABCD is not a rectangle. Okay? So, meaning, no, just by um, saying something uh, in terms of its slope, then we can already say or we can already prove that it is a parallelogram and not a rectangle. Okay? Now, let's have some more example. Let's have this example. Show that the points 6, comma negative 1, 3, comma 0, and 5, comma 6 are vertices of a right triangle. So meaning, if you say right triangle, okay, there is something that is perpendicular. So, perpendicular. So in this case, all we just need to do is to get all the slopes of the given sides of the triangle and then see if there will be an existing slopes or there will be two slopes that are negative reciprocals of each other. Because if that happens, then this means that these 3 points will form a right triangle. Okay, but before that, let's try to sketch first and look at the given figure if it really looks like a right triangle. So you have negative 6, comma negative 6, comma negative 1. So let's just estimate 3, comma 0 and 5, comma 6. Okay, this one. Okay, then let's label again the points. Point A, B, and C. Then get all the slopes. So let's say slope of AB, slope of BC, and slope of AC. So for AB, we have 6 plus 1 over 5 minus 6. So that's simply equal to 7 over negative 1, or that is equal to negative 7. BC, that's also this formula. So that would be negative 1 minus 0 over 6 minus 3, or that is equal to negative 1 over 3, or negative 1/3. And then for AC, we use the same formula for the slope. So that's 6 minus 0 over 5 minus 3. So that's equal to 6 over 2, which is equal to 3. Okay? Take note that B, the slope of BC and the slope of AC, line segment AC, are negative reciprocals of each other. 3, note that 3 and negative 1/3 are negative reciprocals, which means that BC or line segment BC is perpendicular to line segment AC. Therefore, triangle ABC form a right triangle with angle C as the right angle because It is where the angle AC and BC meet, meaning that particular angle, which is angle C, is the right angle of that right, particular right triangle. Okay? Then, let's have the last example. Show that the quadrilateral 0, 1, 4, 2, 3, 6, and negative 5, 4 has two right angles, then find its area. So, what do we do here? We just get all the slopes of these points, okay? And then, just show that they are what? Or they will have some perpendicular lines. So, two pairs of perpendicular line segments for us to say that this quadrilateral will have two right angles. Okay, let's graph first. 0, 1, ah, 0, 1, 4, 2, 3, 6, and negative 5, 4. So this is the quadrilateral. Okay, so let's have A, B, C, and then D. Okay, get all the slopes, AB. Okay, diretsuhin na natin. So that would be 6 minus 4, and then 3 plus 5. So that's equal to 2 over 8 or 1/4. Slope of line segment BC, that's 6 minus 2 over 3 minus 4. Or that is equal to 4 over negative 1 or negative 4. Slope of CD. Slope of CD, that's 2 minus 1 over 4 minus 0. So that's equal to 1 over 4. And then the slope of AD, that's 4 minus 1 all over negative 5 plus negative 5 minus 0. So that's equal to 3 over negative 5. Okay, so what do we notice here? AB, BC, and then CD. Okay, so AD, AB, I mean, line segment AB and line segment BC. Oh, diretsuhin na natin. Therefore, what can we say here? AB, line segment AB is perpendicular to line segment BC. And line segment BC is also perpendicular to line segment CD. But aside from that, there's no other perpendicular. So meaning, what are the right angles here? So the right angles here is angle B and angle C. So therefore, the quadrilateral ABCD has two right angles, namely angle B, namely angle B and angle C. Then you're done.